So last time we discussed this program and you solved this exercise and you find out that on which pin the IO devices are connected. And this is how we write programs in a C language for ARM microcontroller. So this is what you have done last time, so I will not repeat it. Then regarding the LCD, if you remember, you have studied it last time in 5th semester while studying the AVR microcontroller. You interface the LCD with the AVR microcontroller. In the ARM microcontroller, in the same way you can interface the LCD. So LCD is having a pin like RS. RS is a register select. So basically there are two registers are there in ARM microcontroller. One is basically not in ARM but in the microcontroller which is used to drive the LCD. That is actually register select pin will select that registers available from that microcontroller. So one is the command register. If you want to give command to LCD, then RS should be equal to 0. And if you want to write some data into the LCD, then RS should be 1. So that is the function of the RS pin of LCD. Then one more pin in LCD is a read-write pin. The read-write pin is useful to select whether you want to use a LCD in a read mode or a write mode. So normally question will occur in your mind that LCD is the output device, why we should read it? We have to write always to the LCD. There is no need to read the LCD, but sometimes we would like to know whether the LCD is busy or not. So to know the status of LCD, sometimes we read the LCD. Because whenever you send the data to LCD, it will take some time before actually it transmits the data. So if you know that time, let's say you know that your LCD is taking around 100 microsecond to write the data, and if you, for a safety purpose, you call a delay of 1 millisecond, then after 1 millisecond you are sure that data will be written. So in that case you need not worry about checking the status of LCD. So in that case you can directly ground this pin, read-write pin, in the hardware, because now you don't require any reading operation, you require only writing operation. So when you require a writing operation, naturally you can ground this pin, right? So this is actually read-write bar. So if it is active low, then you will be able to write into the LCD. If it is active high, then you will be able to read the LCD. But now we don't require to read at all because we don't want to check the status of LCD. So you can directly ground this pin. Then one more pin is enable pin. So as and when you want to write the data to the LCD, you have to enable the LCD. Right? Then there are actually 8 data lines, but out of 8 we will be using 4 because we will be using 4-bit mode of LCD. So there are two mode of operation. One is a 4-bit mode and another one is a 8-bit mode. So if you want to use 4-bit mode, then to send the 8-bit you have to send nibble twice. So if you send the nibble twice, then you will be able to write the 1 byte using a 4-bit mode. So these are the 4 data lines. Then there are VCC and ground pins, and inside the LCD pin number 1 and 16 and pin number 3 are tied together and then it is grounded. Pin number 2 and pin number 15 are connected with the supply. So this is how we can make the connections. This is the Freescale board available in our lab, but unfortunately we will not be able to use it, but you will be able to do the simulation with help of a Proteus software. So this part intentionally I am skipping because okay, now what we will do here is that we will look at one simulation of LCD interfacing. So in a simulation I have written the program like this. I have defined a header file lpc21xx.h. So this is a header file. which is having a definition of all standard general purpose input output port in this header file. RS is a register select pin, that is pin number 18. Enable is connected with pin number 19. Then we want to display some message on the screen, so that message is defined here, welcome GSC Rajkot. Then this is the routine which will set particular pin on the microcontroller. So this is a IO underscore set P0 routine. So it will set the pins on P0 port. And then as an argument of this function, we will define which pin you want to set. So pin number is an argument to this function. So for example, IO underscore data is equal to 1. Then what we do, we shift that 1 to number of times which you specify as an argument. So for example, if you specify as an argument this RS or 18, then 1 will be shifted 18 times. So on pin number 18, the 1 will be shifted and that particular pin will set. If you want to set pin number 2, then what we will do, we have 1 shifted left 2 times. If you want to set pin number 3, 1 shifted left 3 times. So whatever the argument you are specifying, that is pin number, at that many times this 1 will be shifted to the left side. So that is what this function is doing. And finally, whatever the data is available with us, we send this data to IO set 0. In LED program, we have seen that IO set 0 is for port 0 to set the particular pin. Now which pin we want to set, that is already there in IO underscore data, and that pin will be set with help of this function. So if I am calling this function in my main program, and if I am calling it in this way, IO underscore set P0, and into bracket if I specify 10, then pin number 10 will be high. If I specify here RS, then RS we have already defined here 18. So in that case P0.18 will become high. Sometimes we also require to clear the pins. So this is actually to set the pins, and this routine is to clear the pins. So what this routine is doing, this routine is exactly doing the same job, but now instead of transferring this IO underscore data to IO set 0, we are specifying here IO clear 0. So this is actually what we do to clear the particular port pin. As you have already seen in our LED program, that we are using IO set 0 to set the pin, we are using IO clear 0 to clear the pin. Right? So whatever the pin you want to clear, for example, I want to clear the RS. RS is P0.18. So I want to clear that RS, so I can define here in this way, IO underscore clear P0 into the bracket RS. Then the RS corresponding pin number 18 will become clear. It will become 0. If I specify into bracket, let's say 5, then pin number 5 will be low. If I specify 8, then pin number 8 will low. So ultimately these two functions are there to set the pin of microcontroller as well as to clear the pin of microcontroller. Okay, is there any doubt in this in these functions? If you have any doubt, you can ask. If you do not have any doubt, then I will discuss the next slide. Okay, now next thing that in LCD, basically we are doing two things. We are sending command and then we are sending the data. Command means, suppose you want to clear the LCD, you want to shift your cursor to the left side, you want to shift your cursor to the right side, you want to rotate entire screen to the left, you want to rotate entire screen to the right. So all these are the known as LCD commands. And while sending the command, what we want, RS equal to 0. You must have studied that also in AVR microcontroller while interfacing the LCD in AVR, that whenever you want to say that I want to make I want to send the command, then you will make RS equal to 0. So this function will make RS equal to 0. And this is 1 millisecond delay because we have connected read write pin with a ground. So we want to ensure that this command will reach to the LCD, so we give the 1 millisecond delay. Then LCD underscore write and then CMD. So this command functions we are calling, write functions we are calling, and into that we are writing the command. So there are different commands. For example, if I specify, let's say 80, then 80 is basically to initialize the LCD in 16:2 mode. Then suppose if I write 0x01, then basically it's useful to clear the screen and all that. So ultimately this is basically useful to send the command. And then after what we do, again we give the 1 millisecond delay. Then we we set this enable pin. So IO underscore set P0EN, so that enable we are making equal to 1. Because we want to give pulse in this way. We want initially enable is low. By this command, enable will become high, and then it remains high for 1 millisecond, and then after it we are clearing that enable pin. So ultimately we are giving this type of a pulse. So this enable pulse will allow LCD to send the command and the data. So this enable pulse is very much required for LCD programming. And then after enable pulse we give again 2 millisecond delay, and then we wait for a 10 millisecond, right? Because LCD is somewhat slow device and our microcontroller is very fast, so in between we require to call the delay routines. Is there any doubt in this subroutine, sending the command to the LCD?
No, sir.
Okay, fine. Then the next routine is a data routine. You want to send some data to the LCD, right? So what is the modification you expect in data routine? What is the modification you expect in data routine? In a data routine, only all these things remain same. Only one modification is that while sending the data to the LCD, we are making this RS equal to 1 instead of RS equal to 0. So instead of making that pin clear, what we will do here, we will set this pin. So that is only there in the command routine. Everything else will remain same. So as you can see in this LCD write underscore data routine, what we do here, we set the RS instead of clearing the RS. In previous routine it was clear P0, and now in this routine it is a set P0, and remaining all other things are same. So basically here I have made some mistake. This is wrong. We are basically selecting the data register. We are not selecting the command register of the LCD, right, with help of this command. Okay. Then another routine which we require in LCD is LCD write routine. So in that write routine, what we will do, we will write the different bits to the IO pin. So we have 8 data lines. So in this 8-bit mode, we will be using the 8 pins of microcontroller to drive the LCD. In this situation, I am assuming that I am using port P1 to drive the data lines of LCD, and I am also not using P1.0 to P1.7, but I am using P1.16 to P1.23 to interface the LCDs. That's why 16 is added here. So basically in a for loop I am starting with a 0, and then in this I, that is initially value of I is 0, in that 0 I am adding 16. So initially basically I am setting pin number P1.16. I will set that pin only if data corresponding to that pin is high. So I am doing here data and 1. So if this ending operation resulted into 1, then I want to set this pin, otherwise I want to clear that pin, right? So whether P1.16 will be 1 or P1.16 will be 0, that will depends on what type of data you want to write to the LCD. Corresponding bit is 0, then I want to clear that pin. If that corresponding bit is 1, then I want to set that particular pin. Then after what I will do, I will check for a next bit. So to check the next bit, what I will do, I will shift my data to the right direction by 1 bit position. So when I will do this, my next data that is on a D1 will be available now to me. Again I will check that data whether it is 1 or not. If it is 1, then I will set the P1.17 equal to 1. And if that is 0, then I want to set P1.17 equal to 0. And so on for all 8 bits. So this entire for loop is for all 8 bits of the data which we want to write to the LCD. If you are using LCD in a 4-bit mode, then this loop will be from I equal to 0 to I less than 4. If you are using in a 8-bit mode, then for all 8 bits, you have to check whether the corresponding bit is 1. If corresponding bit is 1, then you have to set the pin. If corresponding bit is not 1, if it is 0, then you have to clear the pin. So this is the routine which will be useful to write data into the LCD. Okay, is there any doubt in this routine?
હા સાહેબ, ગુજરાતીમાં થોડું સમજાવો ને.
આને પાછું ગુજરાતીમાં સમજાવી દો. ઓકે ફાઇન. આપણે શું કરવું છે કે એલસીડીની જે ડેટા લાઇન્સ છે એ પોર્ટની P1.16 થી P1.23 સાથે જોડેલી છે. હવે આપણો ડેટા ધારો કે તમારો છે કંઈક પણ ડેટા આપણે લઈ લઈએ. ફોર એક્ઝામ્પલ તમારે કંઈક ડેટા લખવો છે, એ લખવો છે 1100. આ ધારો કે એલસીડીમાં તમારે એને ડેટા લખવો છે. આવો ડેટા છે ધારો કે આપણી પાસે 000 and 1. આવો કંઈક ડેટા તમારે લખવો છે. તો તમારે આ ડેટા ક્યાં લખવો છે? કારણ કે P1.16 ઉપર, કારણ કે ત્યાં તમારી એલસીડીની D0 પિન કનેક્ટેડ છે. આ ડેટા તમારે ક્યાં લખવો છે? તો P1.17 ઉપર, કારણ કે ત્યાં તમારી એલસીડીની D1 પિન છે. આ ડેટા તમારે ક્યાં લખવો છે? P1.18 ઉપર, કારણ કે ત્યાં આગળ તમારી એલસીડીની D2 લાઇન છે. એવી રીતે 8 બીટ તમારે લખવા છે. તો I ઇક્વલ ટુ 0 જ્યારે હું લઉં છું, ફોર લૂપ પહેલી વખત એક્ઝિક્યુટ થાય છે ત્યારે I ઇક્વલ ટુ 0 થશે. I ઇક્વલ ટુ 0 થશે એટલે શું થશે કે સૌથી પહેલો જે ડેટા છે એ આપણે લખવો છે. અને ક્યાં લખવો છે? તો કે પિન P1.16 લખવો છે. તો P1.16 મારે કરવું હોય તો I અહીંયા 0 છે એટલે P1.16 થઈ ગયું. હવે એ પિન મારે કાં તો સેટ કરવી છે કાં તો ક્લિયર કરવી છે. તો મારું જો પહેલું બીટ સમજાઈ ગયું ને, જો પહેલું બીટ 0 હોય તો મારે ક્લિયર કરવું છે, અને 1 હોય તો ક્લિયર નથી કરવું, સેટ કરવું છે. રાઈટ. પછી આ
સિરિયલ ડેટા મોકલીએ એમાં શિફ્ટ કરતા જાય ને એક એક સેન્ડ કરતા જાય.
પરફેક્ટ. આ સેમ કન્સેપ્ટ છે. પછી આને શિફ્ટ કરીને પાછું જોઈ લો, આ 0 જોઈ લો, પછી આ ડેટા જોઈ લો, પછી આ ડેટા જોઈ લો. જ્યારે આ ડેટા ઉપર આવશો ત્યારે હવે ખબર પડી કે આ બીટ તો 1 છે, તો પછી આ સેટ વાળું ફંક્શન કોલ થશે. આ 0 હશે તો ક્લિયર વાળું ફંક્શન કોલ થશે. રાઈટ.
હા, ફોર લૂપ બીટ માટે બનાવી છે.
Yes.
અને નીચેનો છે
હા,
ઈ ડેટા 0 છે કે 1 હોય,
એ ચેક
ઈ
કરો.
જેટલામાં પિન ઇન્ક્રીઝ થઈ હોય,
હા હા
16 ને બદલે 17 થઈ હોય તો 17 ને 0 કરે કે 1 કરે, એવું ને?
હા, બસ
ડેટા પ્રમાણે.
પરફેક્ટ. યસ, એ રીતે જ છે.
તો સાહેબ આપણે આમાં 32 બીટ નો ડેટા.
હા, તો 32 સુધી કરી શકાય. I ઇક્વલ ટુ 0, I લેસ દેન 31. પણ આપણે એલસીડીમાં તો 8 જ પિન છે, એટલા માટે આપણે 8 સુધી કરીશું. કોઈક ડિવાઇસ એવી હોય, ધારો કે 16 સેગમેન્ટ ડિસ્પ્લે તમારી પાસે હોય, કે બીજી કોઈ ડિવાઇસ હોય કે જેમાં 16 બીટ હોય, તો તમે આ લૂપને 16 વખત એક્ઝિક્યુટ કરો તો ચાલે.
સમજી ગયા.
Then after initialization of port, there is one routine to initialize the port, whether the port is input port or output port. So in this case, we have connected LCD data lines with P1.23 to 1.16. So corresponding ones are there. So because of that, the data is like this: 0x00 FF 0000. So with help of this declaration, we are saying that pin number 1.16 to 1.23 are output pins. Similarly, we are connecting RS with P0.18, enable with P0.19, so that 2 bit is 1. So corresponding bits, if you make 1, then this will be your bit pattern: 0x000C and then 0000. Right. If you are connecting this RS to P0.0 and P0.1, then this bit pattern will become 0x0000003 because last two will be 1. So depending on where you are putting 1, corresponding number you have to put here in the initialization, right? Let's say for example your entire port P0 is output port, all the output devices you are connecting with this port, then all this will be FFFFFF. So all will be 1 in that case. So this is simply initialization of the port. This is actually initialization of LCD, which you have already done in AVR microcontroller also. So ultimately to initialize the LCD we send the command initially 0x38 to initialize LCD in a 2-line mode 5x7 matrix. So basically there will be 5 columns and 7 rows to display the character. Then we call the delay of 50 millisecond. Then we send another command 0x08 display off cursor off. So if you want to make the display off, then we are sending 08. If you are sending 01, then you are clearing LCD. If you are sending 06, that means you want to shift the cursor right direction. That means you want to start the entry. The first entry will be on the left side and your cursor will move towards the right side. So that is normally what we do during the writing process. And once it is due, you can make the display on with help of this command 0x0c. So all these commands are available on LCD datasheet. There are many commands are available, like you can rotate your display to the right, rotate your display to the left. You can blink your display. So there are different commands for the LCD which you can use. But these are very basic commands which is compulsory initially before you use the LCD. These are the compulsory commands that you have to give to the LCD. Then if you want to send some message to the LCD, then we will be calling this LCD routine frequently. For every character we will call this routine. So what we will do, we will have a message in some pointer message. Then what we do, we take these characters one by one because we are using here message into square bracket of I. So initially when I equal to 0, the first character will be displayed. So for example, if you want to display welcome GEC Rajkot, then W will be there in this and we are writing the W. Then whenever that character is written, we will say I++. So pointer will be incremented to one position. So next it will point to E. So ASCII equivalent of E will come into this and then it will be sent to the LCD. And like this entire message you can display until it reaches up to the null. So until it reaches to the end of the message, the entire message will be written to the LCD. And then we will write saying here I++. So this is how you can specify any message and then that message you can write to the LCD. So this is actually our main program. So to make our main program very simple, what we have done, we have written all the different routines. So our main program is now very small. The first of all, initialize port. Our port 0 and port 1 are declared corresponding pins which we are using to interface the LCD are declared as an output pins in this initialization. Then we call 1 millisecond delay. Then we initialize the LCD, again 1 millisecond delay. Then 80. So on the first line of the LCD we are displaying this message. MSG is written, welcome to Government Engineering College, that is first written. We have declared it as a string. And if you don't want to declare a string here, you can also directly write the message here like whatever written in the second line. So we are sending another command 0xC0. This is because we want to write on the second line of the LCD. The message is EC department. So here I am not using any variable, I am directly specifying the message. Here also you can do the same thing. Here you can, instead of writing MSG, you can directly write the message whatever you want to display on the LCD. And then while one. So after that you don't want to do anything because you have sent everything to the LCD. Now LCD will do its job independently. Now your microcontroller is free to do some other task. I think the LCD portion is Okay here. Now I will show you the kill program as well as I will try to show you the simulation of this program. But before that I will tell you that wear mask whenever you go outside. Always wear the mask. Keep social distancing. Nowadays, we see a lot of crowd in the market and people are not maintaining the social distance. So please keep social distancing because it is required, because still corona is there. Sanitize your hands regularly. Thank you very much. Meanwhile, if you have any doubt, I can clear your doubt, and then after I will show you the simulation. Let me show you the kill simulation. Okay, I have written the same program in this kill. The program which I shown you was actually for LPC 2129, but the same program I have written here, but it is for 2294. But program will remain same. There will not be any change in the program, right? So this program is visible to you on the screen.
Yes, sir.
Okay. So this is in a comment I have written LCD data lines are connected to pin P1.16 to P1.23, and I am including here LPC 22xx.h. So in our in PPT I have shown you 21xx.h. So that was for 2129 to 2131, 2124, all those ICs. We have also 22 series. So in a 22 series, the header file is lpc22xx.h. So that is the header file. RS is a 16, enable is a 17. So ultimately we are connecting this RS with a P0.16, enable with P0.17. And we want to display this message. So message is written in this message string. Then this function IO_set doing the same job which I explained you in the PPT. So this is actually basically to clear the particular pins of the port. This function IO_clear will clear the particular pin. So whatever the pins you specify, that will be cleared. This write byte is very much similar. We have already discussed it in the PPT. So these are initially functions written. Void delay a millisecond, so it will provide the delay in a millisecond. So the delay routine, I am not using standard delay routine, but I am using the customized delay routine in this program. Then LCD write command, this also we have already discussed in the PPT. The same function is written here. While sending the command, we will make RS equal to 0. So that's why actually here IO_clear into bracket RS. So that particular pin will become 0. Then we write the command byte. Then we set the enable pin and clear the enable pin to basically to send the pulse on enable pin. So to send the pulse on enable pin. Then LCD write data. So only one change is here. Instead of IO_clear, I am writing here IO_set. Everything else will remain same. So this is for writing the data to the LCD. And this is actually a function to write the message in the LCD, where what we do, we take characters one by one from the string and write it to the LCD with help of this function LCD write_data. So basically, while writing a message, basically we are sending data to the LCD. This is initialization, LCD initialization routine, where we are sending different commands to the LCD. And here I am defining integer d1, d2, temperature. I am trying to display some temperature on the LCD. So that's why normally temperature sensor will be there, and sensor will sense the temperature, and then it will be displayed on the LCD. This is actually definition of IO pins. Whatever the pins we want to use as an output pin, the corresponding pin, corresponding bits will be 1. We call the initialization function, we call the commands, then we display the message, we display the message again, second message on the second line, and after displaying both this message, we clear the LCD, and then after we want to display some temperature on the LCD. So you can always interface the temperature sensor and the temperature sensor data you can send it to the LCD. But you know the temperature is, let's say you have a 41 degree or 35 degree, so that 3 and 5 you have to separate out. So to separate out that, what we will do, we will do the modulo operation. So let's say if you have a data is a 35, I will try to explain it here. If you have a data is 35, but if you want to separate out 3 and 5 here, so what we will do, 35 modulo operator by 10, so this will result into a 5. So 5 will be separated out, and then after we will divide that by 5 by 10. So this is a division by 10. So when we do the division by 10, what it will do, it will divide it by 10, so it becomes 3.5, and then again we perform the same job, modulo operator by 10. So what it will do, 3.5 modulo operator by 10 will give you 3. So this is how you will be able to separate out 5 and 3. The 5 is available in a D1 and 3 is available in a D2. You are sending D2 first, that is 3 first, because we are using a left entry. So 3 you will send first and then you will send the 5. But before sending, we are adding 48 because we want to send the ASCII equivalent of the data. So we add here 48 in this number. If you want to add the hexadecimal number, then you have to add 0x30, right? So the 5 will become 0x35 in ASCII, and 3 will become 0x33 in ASCII code. So this code you will be sending to the LCD, and then after doing that, you can just go to the infinite loop. So this is how you can write the program, and then you can build the program to check whether there are any errors are there or not. If there are no errors, then you will be able to simulate this program. So to simulate the program, what I will do, I will open the Proteus. In a Proteus, actually I have ARM processor IC. Then what I will do, I will place the LCD here. So in a component from the libraries, I will find out the LCD. I will select the 16:2 LCD. I will put that LCD here, and then I will make some connections. Now connections will be as per our software written. So RS I have to connect with 0.16, enable I have to connect with 0.17. So this pin I will take, and then I will connect with the RS. Then I will take this 17, and will connect with enable. Then I will put one ground here. So this ground VSS I will connect with the ground. Similarly, this VEE also I will connect with the ground. Similarly, RW I want to connect with the ground because I don't want to read the status of LCD. Then after I will also put the terminal power. To connect this VDD with the power. Then after I want to connect the data lines. Now let's look at where, as per our program, where the data lines are connected. Data lines we have to connect from 1.16 to 1.23. So let me check whether the same port pins are there. Okay, here it is there. So 1.16 data lines are connected. So I will connect this D0 with 1.16, D1 with 1.17. So similarly I will connect all these data lines. Pin number 1.23 is the last pin which will be connected to the D7. So this is how we have connected our LCD. Now I think all the connections we have made. Now only job is that we have to specify the hex file for this. So let's double click on this and try to find out the hex file. As we can see that LCD is there, ARM2294, and then LCD is there, lcd.hex is available here. The latest time is 21st October and this 11:39. So this is the latest LCD which we can open. And then let's debug this program, run the simulation and check whether everything is fine or not. If there are some errors, then the message will not be displayed on the LCD, and then we have to do some modifications in the program. So as you can see, there is some error because all these pins are not blinking. It is continuously high. So there is either some issue at the program level, or maybe because one major mistake what I made is here that I have written this program for 2294. Let me check whether the same microcontroller I have taken here or not. Let me check here. If I have taken, then I have taken this 2124 microcontroller. So that's why it's not actually working. Both is different actually, right? So what I have to do, I have to use the same microcontroller for which I have written the program, right? So that is the one mistake I have made. Let us try to solve that mistake. Let me open one more file. I must have a 2124 also. Yes, 2124 is also there with me. It is also having LCD program. It's a very simplest program actually. Same program but somewhat simplest, where temperature reading is not there, everything else is there. Okay. LCD RS is 10 and 11 and LCD is 2 to 2 onwards. Okay, let me check it here. Yes, I will do some modifications. So first of all, what I will do, I will remove the connections whatever is done here. First of all, I will stop the simulation, then I will remove the connections. I will also remove this part. I will make this all connections again. I have to do this from P0.2 onwards. I have to connect with the D0 pin, then P0. So you can connect it with any pin, only the program will change. Every time your program will change. So as per this program, data LCD data starting from 2, so 2, 3, 4, 5, 6, 7, 8, 9 we have connected, and RS is 10 and 11. And let me check which port pin we have taken here. IO clear 0, so port 0 we are using. Here also IO set and IO clear, both routines are basically for port 0. So everything is, all the pins are basically connected with port 0. So 10 and 11 we will be using for RS and enable. So RS we will connect with pin number 10. Okay, it will be difficult to connect from here. What I will do, I will slightly shift this IC so that we will be able to make the connections easily. And then with pin 11 enable pin. So I think the connection is done now. Now specify the X file. We have a 2124 inside that LCD, and then let me check whether X file is there. X file is there. Okay. Okay, and then we will run this program. And let's check now everything is there working or not. Some data is coming here. You can see here is blinking red and blue dots are there. VSS is blue, that means it is ground. VE is also ground. VDD is red, so it is okay. Only the thing which is not coming here is RS and this enable. These two are not coming, so we have to check only for that. 10 and 11 both are having some issues. Check it here. 10 and 11 is there. Let me build again this. Build and then let me open this ADC LCD, right? And This is actually for 21 XX microcontroller. So let's try this program. Zero error, zero warning. We will specify corresponding object file. Where is the object file of that? This is showing actually older one. I don't know why. Zero error, zero. Okay, let me check whether check target options. Output create hex file is still there. Okay. Then target is also there. Device is 2124, that is also correct. User, okay, linker and debug. Okay, everything is fine. So in this case, we should have a connection like this. RS, RW enable this pin, ADC pins, and this data pins. This is 4-bit.